Lesson 101, Complex Shapes. Our objective is to use formulas to find the perimeter and area of a complex shape and to identify complementary and supplementary angles. The skills that we bring to this lesson are knowing how to use formulas to calculate the perimeter and area of squares, rectangles, parallelograms, and triangles. And we also need to be able to round decimal numbers to the nearest hundredth, tenth, and whole number. The new concept today is that in this lesson we will practice finding the perimeters, areas, and interior angle measures of complex shapes. First, we'll consider perimeter. The figure we're going to look at is an example of a complex shape. We're going to notice that the length and the two of the sides are not given, and we will first find the lengths of the unknown sides, and then we will find the perimeter of the shape. In this book, we're going to assume that the corners that look square are square. Here we have our shape. It sort of looks like a rectangle with another little rectangle attached to it, or you could look at it that it's a rectangle with a little chunk removed from it. And we call this a complex shape because it isn't regular. It has several sides that have different lengths. If this were just a rectangle or a square, we would call it a regular shape, but instead it's complex because you can either look at it as made out of two other shapes or that there's a section missing from the shape. Now we see that in this figure, it's 7 centimeters long, and I'll show you that. That's down here, 7 centimeters long. And the sides are marked B, B and 3 centimeters together making the 7. So let's look at that. My screen's a little bit fuzzy, but there's a B here and the 3 centimeters up there. I hope it's clearer for you. The sides marked B and 3 are equal to 7 because they're opposite sides. In other words, this one goes straight across in one line, this one goes straight here, but it also continues up here, so the B and the 3 together would be the same as the 7 on the bottom. So that means that B must be 4 because 4 plus 3 would make our 7. So I hope that that's clear in your picture. Now the width of the figure is 6 centimeters and the sides are marked 4 centimeters and A up here, and together those make our 6 centimeters. So again, 4 plus A makes 6, so A must be 2. That's how we find those missing pieces. When we've found that B is 4 and that A is 2, we can add the lengths of all the sides together because remember, when we're finding perimeter, we're finding the distance all the way around the outside of the figure. So all we have to do is add all those sides up. Now the hard part is being careful that you've included all your sides. So if you're trying to be sure of that, you might count them. You might say there's 1, 2, 3, 4, 5, 6 pieces here. Okay? So there should be 1, 2, 3, 4, 5, 6 pieces down here when we add them together. Now, they've done it in a rather long way because they've taken our 7 and our 6 and our 4 and our 2 and our 3 and added them all together in a long string there. Some of you might see some possible quicker ways to do that, but they've come to a total of 26. And again, although you have to be very, very careful that you don't leave a piece out, you might see that you could have used a 7 here, a 6 here, a 7 here again, a 6 here again, because that would have accounted for all those pieces without having to add them all separately. I'm not sure if I want to really clarify that. Some of you will see that, and some of you just need to know that it's probably okay to just add all the sides together and just count and make sure that you didn't miss any of your pieces. To clarify what I meant there, I want you to see, and maybe this is a good important thing for you to see, and that is that this side is 7. Remember we said that 4 and 3 was also 7? So our two 7s there are a quicker way to do the problem. 7 plus 7, or two 7s, we would just know were 14. Then when you go to the other sides, we have 6 here. Remember we said 4 and 2 made 6 again. So we know that that section are two 6s, or 12, and we get much quicker to our 26. We'd get the same answer though. For some of you, I wanted you to just see that when we find the perimeter, if we know the two sides here, we know that these other two sides are going to correspond. We can get to our perimeter a little faster than adding all the individual tiny pieces together. Now, in example number 1, we're going to find the perimeter of this little L-shaped figure, which looks like two rectangles, or it looks like a larger rectangle with a piece taken out of it. Kind of depends whether you look at it as the cup is half empty or half full. This was either a giant rectangle that lost a piece, or it's two rectangles put together that could be divided here or here. So there's a lot of things to observe. But to find the perimeter, all we're going to do is add all the side lengths together. Some of them are not given. 2 of them are not given in this illustration, and we want to write an equation to find those missing pieces. So we know that this side is 10, and we know that this is 4, and we know that this one is an unknown. So our 4 and our 6 have to make 10. And that's where the equation down here is coming from. 4 plus a missing piece makes 10, so the missing piece is 6. On our width, we have this side, and we see that on our width we have 2 over here, and we have a total over here of 8, and we have an n over here that's our missing piece. So something has to make 2 into 8, and that would be 6. So this missing piece is 6. Again, we can either count that we have 1, 2, 3, 4, 5, 6 pieces. Make sure that 1, 2, 3, 4, 5, 6 get down here. Or if we like to do mental math and we want to be a little faster, we know that this is 8. 2 8s are 16. 2 10s are 20. And we get 36. So you can do it by mental math, or you can do it by a longer equation. Both will get you to the perimeter rather quickly. Also, if you're in a big hurry, if you were in a race or you were doing this another way, as soon as you see this total and this total, you don't necessarily even have to find these missing pieces. You can just know that if this is 10, this side is 10, and if this is 8, then this side is 8, and you can do it without actually finding the 6 and the 6. So it's just a little shortcut if you're ever wanting to impress somebody with how quickly you can do this. This is more of showing all your steps and your reasoning for your answer, but sometimes you just want to get to the answer quickly. In example number 2, we have a new challenge. We're asked to look at 2 figures and figure out which one has the greater perimeter. We can first estimate and then compute the perimeters, and we can estimate to the nearest hundredth. It looks like the one on the left is going to involve finding the perimeter or circumference of a circle, and the one on the right has everything already given. So let's look at the one on the left and find out how we're going to find that missing curve that's over on the right-hand side of the figure. We're going to look at this 4 and know that if there's a 4 here, there's also a 4 over here, and the 4 forms the side of a rectangle, and it also forms the diameter of the semicircle that's attached to the side of the rectangle. So you can see here they've labeled 4 on this side and 2 for the radius over there, although if we use the diameter it would be 4. Now they've used the formula so circumference is 2 pi r, but circumference can also be pi times the diameter. So either way you either have 2 times pi times 2 or 4 times pi. We've rounded pi to 3.14 because pi does not terminate and does not have a whole number or an ending number because it's irrational. We always round it, and the common rounding is to 2 places, and we say that pi is 3.14, even though we know that really it isn't. It's a little bit more than that, but we don't have to go any further than 2 places. So when we want half this circumference, we first calculate the whole circumference as 4 times pi, which gave us 12.56, and then we cut it in half and get 6.28, and that is really the circumference of that semicircle. So now we can get this whole perimeter by adding our tens, our 2 tens, our 4, and our 6.28 for a total of 30.28. The other figure is easier because it already is labeled 10, 13, 4, and 5. So when we add those up, we get 32, and we see that this little triangle actually creates a greater perimeter than this semicircle. This might be useful information if you were trying to choose the shape of a fence or something, and you either wanted to save on material cost. So you might go with this shape because you'd save a little bit on materials because it would be slightly smaller. Now we'll practice finding the area of a complex figure. And one way to find the area of a complex shape is divide the shape into 2 or more pieces. We can do this because they are complex. We find the area of the parts and then add them together. Let's consider